Quit talking, do the little transit.
Alright, so graph paper. Everyone get out a piece of graph paper. So we're going to be using these guidelines to draw each of our waves. Okay, starting with number 1. So let me go ahead and set up our grid. Okay, so we have our grid here. So step 1 says that we need to draw our y-axis. Do you guys have rulers? Good. Just borrow. Okay, so the first thing you need to do is draw our line 1. We're going to count 4 squares. Let me bring up my line tool. 4 squares from the left on your graph paper. 1, 2, 3, 4. And that y-axis goes all the way down your page. You want to do this, I would do it in pencil. And you want to do this long ways up and down, not landscape. Yes.
And you want us to like count the lines after the holes? With the holes?
No, do it just from the edge, not from the hole, but from the edge. Alright. Yes. That's fine. If you start off with a half square at the beginning, just count that as a hole. It's not that big of a deal. Or if you've already drawn your line, that's fine. I mean, it doesn't have to be exact. Hopefully, I get a straight line. I'll be happy with that. You have to show. You good? Perfect. Okay, and now you guys have these problems on your half sheet. Okay, I'm going to write down number 1 on my graph paper up here. That's just so for the recording that information is there. Okay, you're not writing this down on your graph paper. So we have you're given for number 1. Number 1, our wave is going to be there. We're given an amplitude of 0.5 meters. We're given a wavelength of 1 meter. And it tells you that you're going to have 5 vibrations. Okay, so let's talk about what these actually mean. Our A stands for amplitude. So how many squares pi is our wave going to be? Well, before we know that, we have to look at our half sheet with our scale. So we have a distance scale. 1 square equals 0.25 meters. And we have a time scale of 1 square equaling 1/10 of a second. Okay? So using that, we could just now think of this as using quarters. Okay? And money. So if we have 50 cents here for an amplitude, how many quarters make up 50 cents? 2 quarters. So our amplitude is going to be 2 squares pi. Okay? And low, because we're talking about crest and trough. So we need that because, as our directions say, number 2, we have to calculate the amplitude plus 1 so we can figure out where our x-axis goes. So we have an amplitude of how many squares? 2 squares plus 1. So that makes 3 squares. So from the top, we are going to count 3 squares. 1, 2, 3, and draw our x-axis. Yes?
Why is there a plus 1?
because we want, the question was why do we have +1 added to our amplitude? That way we will have a 1 square buffer between each of our problems. That way your waves won't be touching each other.
That makes sense. Okay.
So now that we have our x-axis, so our amplitude, this is our height, right? I'm going to label mine. Oh wait, I need to put that in our pen. I'm going to label it height. So above your amplitude on your half sheet, put an H there. Okay? Because we're going to do this obviously as a class, and when you get to the next one, we'll forget everything we did. Question.
Where?
Above your A on their half sheet. Okay, so let's talk about our wavelength here. Your wavelength, which is your 1.0, that is also, so this is our height. What is this going to be?
Length of the wave.
Length of your wave. Okay, so I'm going to label that with an L for length on your half sheet. And since we're labeling things, a vibration is the same as a wave. Okay, so if we have 5 vibrations, that just means that that's our number of waves. So we have, in this case, number 1, we have 5 waves because there are 5 vibrations. Okay, so we have our x-axis. Now we need to set up a series of dots and dashes. And after, the whole point of this is to make a dot diagram, then all you'll have to do is connect the dots and draw your wave. Okay, so using the wavelength, and this is number, what number is it? Number 3? Number 3 in your directions?
Oh.
Yes. Okay, using dots and dashes, okay, you're going to make a dot for each wavelength. So our wavelength is 1 meter. How many squares? 4. $1, 4 quarters. Okay, so along our x-axis, start with the dot, and then I'm going to go 1, 2, 3, 4. Put a dot. That's 1 wavelength. How many waves do we have?
5.
5. So I need to do that 5 more times. 1, 2, 3, 4. So now I have set up 5 wavelengths. That last dot also indicates my ending point. Okay? My end point.
You want to write that?
Just know it. The problem is we have calculations we have to put there. What might not hurt to write that. You do it small. Right, Rose. Okay. Second part. Okay, so now we're adding our dashes. Okay, so we put our dots. Now we do our dashes. So again, along our x-axis here, we just put a dash halfway between each wavelength.
Why do you put a dash in between? Like half the length?
Each dash and dot is going to indicate where the wave crosses the x-axis.
Oh, okay.
And this will become more apparent whenever we set it all up. Okay, we have our dots, we have our dashes. Now, we need to figure out our amplitude. And with that, we will figure out where our crests and where our troughs go. Okay, so we have an amplitude, 0.5 meters. How many squares? 2 squares. So we're going to go 2 up. Now, your amplitude, because remember, your amplitude It's at the top of your parabola, right? So that has to be in between, in the middle. So you're going to go in between your dot and your dash, go up 2, and put a dot.
On each of them?
Well, where are you going to go on the next one? Yeah, that's your crest.
You go down.
Then you have to go down 2 for your trough. Making sure it's in between the dot and the dash. Yes.
Why is it 2?
Why is what 2?
You said the amplitude is 2.
0.5. It's 50 cents. How many quarters make 50 cents? So you're going to continue this pattern. Throughout. What is your wavelength? How many squares?
Wait,
4 squares for your wavelength. How many squares are there between your 2 crests? 4. How many squares between your troughs? 4, right? That should be for each of them. Okay. Questions on that? So we've set up our dots and our dashes. Now starting at your origin, you just connect them all. Okay? If you do not feel comfortable drawing curvy lines, you can draw straight lines if you want to. And just make them jagged. That's fine by me. Okay? If you want to make it look very, very straight.
does it matter which one?
No. As long. The advantage to using a ruler is that it's harder for you to stray off course. Okay? But it also takes more time.
That's better, guys.
It's up to you. I don't like using a ruler, but it's your call. Whatever you feel more comfortable with. Notice I did not go past my endpoint. Doing so would mean I'd have more than 5 vibrations. I'd have 5 parts of waves.
Oh.
So in addition to giving you those variables on number 1, they also ask 2 questions. They want to know the frequency and the period. So, over to the side, I'm going to calculate my frequency. Now, on Friday, we talked about how to calculate frequency, not with the equation 1 over p, because we don't know the period, so we can't use that equation. But I talked about being able to look at a graph and doing something to calculate frequency. Alex, what was that?
Crest plus 12 divided by 2 and 1 second.
That's right. So crests plus troughs in a 1 second period divided by 2. Well, we have not set up our 1 second period yet, okay, because we haven't needed it yet. So let's go ahead and do that now. So this goes back to our time scale. 1 square equals 0.1 second. So how many squares equals 1 second? 10 squares. So I'm going to make a dashed line all the way down at 1 second. So I don't have to do this every time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Dash line. So I need you guys to go ahead and count over 10 and make a dashed line all the way down on hers as well.
10 from the Y.
Yes. Yeah, that's a good point. Not 10 from the edge of your paper, but 10 from wherever your y-axis starts.
Are we doing all of our problems on this one graph paper?
They won't all fit. It will take 2 sides.
So we'll need to graph papers.
Okay, now that we have our 1 second mark, we said to find our frequency, we are going to add up our crests and troughs in a 1 second area and divide by 2. So I have 1, 2, 3 crests plus 2 troughs. So 3 plus 2. We'll take that and divide it by 2 to get 2.5. What's our unit?
Hertz.
Hertz. I do want you to show your work.
So that's all I have to show?
Yes, that's it. Real simple.
Why do you divide by 2?
Because a wave is 1 crest and 1 trough.
Okay.
Yes, Max?
Do we circle like we did the yellow?
You do not have to do that. Yes, it's all right if you do. If you want to circle your crest and trough, that's fine by me. The more visual you can make this to remember, the better. Okay, you also need to calculate your period. All right? What was our equation for period?
1 over f.
1 over f. Okay? Do we know f?
Yes.
Yes. So P is going to equal 1 over what we just calculated, 2.5 hertz. And when you put that in your calculator,
If you have it.
0.4. 0.4.
anyone have the right answer?
No, wait, hold on.
Mitchell, what do you think? Raise your hand if you're sure. Kim?
0.400. That's pretty safe.
Alex, what do you think?
4.00.
Okay, that would be scientific notation. Yes.
1.4 seconds.
Thank you. I wanted a unit, of course.
So we do need 360.
0.4 seconds. Now, for this, we don't. I don't really care.
Yay.
Now, here's what we're going to do. We're going to take this, our value, okay, our period value, and check it with our diagram. So what is your period?
Our period is 0.4 seconds.
Okay, that's the value of it, but what does it represent?
How many seconds?
How many waves per second?
That would be frequency. Cassie?
Time it takes for one vibration to occur.
Okay, yeah. It's time per wave. Okay? So one wave is right here. How many squares? 1, 2, 3, 4 squares. And if we look at our time, how many seconds would that be? 0.4 seconds. So that not only checks your math here with your period, but it also checks your frequency, right? Because if you didn't get this frequency right, the period would be wrong as well because you use frequency in the problem. Okay, so it does a 2 check by doing that. That's number 1. So number 1 is done. So let's set up the x-axis for number 2, and then you'll be on your own.
How much space does there need to be between these?
So we go back to number 1 in our directions, in our list of guidelines.
How many?
So what do you do?
When you have points for this left.
Calculate amplitude squared plus
Oh
1.
gosh, yeah.
Okay, so our amplitude plus 1. So what is our amplitude for number 2?
1 meter, which is 4 squares, plus 1, which is 5 squares.
Okay, so our amplitude for number 2 is 1 meter. So that's 4 squares plus 1. That's going to be 5. Now, that's 5 squares from the trough of our previous. Okay, it's not 5 squares from the other x-axis, or they'll hit each other. So from our trough, you go 1, 2, 3, 4, 5, and then draw a yellow, apparently, x-axis. And that will be set up to do number 2. Okay, you do the same steps. Then you do your dots, your dashes, then you do your amplitude, define crest and trough, crest, trough, connect your dots, and then calculate your frequency and your period.
Alright.